So this is our video on work, and you'll notice it is much shorter than our video about heat. So the only type of work that we will talk about calculating is pressure volume work. And so we are talking about a gas expanding against a constant external pressure. So what we are looking at in general, we like to draw these cylinders that have pistons in them, and this is our initial situation. And the external pressure, we're talking about a constant pressure pushing down on the outside of this piston. And then there's some kind of expansion that happens, and this is our final condition. And we still have some constant external pressure pushing down on this piston. So this expansion is work on the surroundings. So work by the system. And we can calculate it by doing negative P external delta V. And that's it. Now, of course, there's a little bit of a caution and a trick and all of that stuff. Right, first of all, this is the external pressure. So do not try to calculate the pressure of a gas inside the cylinder, because that pressure is not what's contributing to this calculation. It's the external pressure. Second of all, if we are trying to find overall, right, we're going to take this work value, add it to heat, get a change in internal energy. Take a look at the units that you get here. So pressure is usually in units of atmospheres, and then a final minus initial volume is going to give us liters. So this calculates work in liter atmospheres, which is not helpful to us. So we do have to do a unit conversion after doing this calculation. And the conversion is that 1 liter atmosphere is equal to 101.3 joules. So it will be a quick conversion for you to do. All right, so we should always do a quick example, so let's do one here. And as you might expect, inflating a balloon is work. So if you inflate a balloon from a volume of 0.1 liters to 1.85 liters against an external pressure of 1 atmosphere, how much work is done? And we want to know how much work in joules. Okay, well, work equals negative P external delta V. So the opposite of P external is 1 atmosphere. My volume, the final volume, is 1.85. The initial was 0.1. So this gives me a value for work equal to negative 1.75 liter atmospheres. So now I need to convert this, so I need to multiply by 101.3 joules per liter atmosphere. And my work value is negative 177 joules. And you should find that the sign convention is correct. So we should be showing work on the surroundings, which is work by the system, which should have a negative value, and that is the case. So the sign conventions will always be upheld if you have your delta V values calculated correctly.